But
okay, so I'm starting once again.
no, it's okay now. We're live.
Okay, perfect.
We should be at least.
Yes,
yeah. Okay.
Great.
So, welcome all. Good evening. Thank you for waiting for a second, and thank you for coming. My name is Paweł. I am the president of the Data Science Club, a student research group at the Gdańsk University of Technology. Usually at this time, I conduct a weekly series, Data Science from Scratch. But this week we are joined by a special guest, Olgun Aydın, a senior data scientist at PwC here in Gdańsk, who will tell us about the machine learning development cycle. Welcome.
Thank you, Paweł, for this warm introduction. And also thank you for organizing such webinar series. I think that's pretty much important for this domain. And also it is very much appreciated that as a student, you are taking such initiatives. So I would like to appreciate all of the members of the clubs as well. And also Karol Filiskowski, who is also taking very good responsibility related to this. All right.
Oh, sorry.
Please go ahead.
I'm extremely grateful and excited for the lecture and for your time. And yeah, I think that I'll leave you with the audience now.
Sure. Perfect.
Thank you.
Perfect. Well, thank you. Okay, so I will quickly share my screen. Okay, it should be here. All right, so welcome everyone once again. And as Paweł mentioned, my name is Olgun Aydın. Excuse me. And I'm working for PwC as a senior data scientist and technical lead in financial crime units in technology stream. I'm also working as an assistant professor in Gdańsk University of Technology in Faculty of Management and Economics in the Department of Economics. So I'm really glad to be here once again. Thanks a lot for everybody who put effort to organize such event. And maybe just a little bit background about me. So I've been living in Poland for 3 years. Unfortunately, my Polish is not enough to conduct such event in Polish. So that's why we are going with English. I hope it will not be a problem for you. So I have PhD from statistics. Basically, I have actually education related to statistics. I have bachelor and master degree from statistics and from statistics as well in PhD. And I was focusing on deep neural networks during my PhD thesis. And I was trying to propose different state-of-art architecture for predictive maintenance studies, predictive maintenance approaches. And so I'm trying to also write some papers related to application of machine learning on different domains. And I find it quite interesting to play with data from different line of businesses and different domains. And generally speaking, I really like playing with data. I really enjoy playing with data. So maybe just a little bit background about what I'm doing in PwC FCU, Financial Crime Unit. So it might sound scary, financial crime and so on, but we are not doing something scary. So we are just trying to automate some processes related to prevent financial crimes within Financial Crime Unit. So as a technology stream, we have a goal and mission to provide automated solutions to both our own employees and also other companies on the market. And so as a data science team, so I'm also, like I said, acting as a technical lead for this team. So that was only me 2 years ago. So right now we are growing and we have more people. And so what are we doing? We are focusing on machine learning, statistical modeling, and artificial intelligence to provide some automation. For example, just to give us some example related to this, and we are trying to understand what is written in unstructured text using some NLP algorithms, and we are trying to predict some failures which might happen on the process before they happen, and then we are able to provide some red flags related to this process, and then people from people from the related departments can take care of this before such failures happen. So in Gdansk University of Technology, and this semester, and I'm conducting together with Karol Filiskowski an Essentials of Statistics for business management students, and also mathematical statistics for data engineering students. I'm also quite a lot enjoying having classes with very skillful and very smart and intelligent students, and it is always a pleasure for me to have classes. So moving on, and I would like to show you the agenda today that we are going to cover together. First, I will try to put some light on a sort of an introduction and kind of put some light on the motivation behind this talk. And also I would like to try to explain you what does machine learning development cycle mean. And after this part, and then I will start describing in details, which steps are included within the machine learning model development cycle. And then we will be answering those questions together. And then I would like to also show you how we answer those questions. So the questions, as you see on the screen right now, how to understand data, how to interpret machine learning models, how to be sure that models are still good. So, and then I would like to share with you how we answer those questions within the team to solve real life problems. And we also developed some internal tools from the scratch to be able to answer this data, to be able to answer those questions, and then also to be able to explain those answers to the business. So this is, I think, also a very important point, because as long as you're not able to explain what you did to the business, so unfortunately, to think what you did wouldn't be used on the production, because business have to be convinced. So let's start with the introduction. And so maybe let's talk about machine learning concepts. So I don't want to go into this detail. I'm sure that Pavel already mentioned about them during the previous talks and webinar series. So also today's content is not going to be about going into details of machine learning models, but mainly we will be talking about how those models and how this model development works in the real life. So as you know, that in machine learning, AI, data science is definitely part of our lives, right? So, thanks to actually the internet and then growing big data technologies and so on. So even though our mobile phones are producing, terabytes of data, and a lot of companies are using this data, and then they are understanding a lot of patterns, and then they are trying to provide a lot of solutions related to this data. And even though some products are, or some applications are free of charge, but actually, as you might guess, also on the background they are processing your data and then trying to understand the patterns in your data. So this is actually quite interesting and very new kind of a business model for such companies. So you are using their service free of charge, but on the background, they are having a lot of insights from your data. And maybe I would like to also say this one. I really like this phrase, and we are living in a data age. So, and there is also saying that data is new oil. So the companies or institutions, authorities, the more data they have, and then the more skill sets, and then the better skill set, and the bigger potential they have related to processing this data and understanding data, the better position they will have on the market, or the better position they will have against their competitors, or researchers or authorities, institutions will be able to do something much better for the society, because we shouldn't be only talking about some businesses which are commercialized, right? So, and there are also a lot of research are happening, and they are also basically very important for the society. Okay, and maybe quickly move on with the introduction. And as we know that machine learning models are trying to understand the pattern in the data which has been already observed, or they are trying to understand the data on the fly, and then what is going on with this data, and then sometimes they are providing some predictions, and this can be some type of labels, so labeled data, I don't know, like they can predict some classes and some errors, and so on and so forth. Or sometimes even some clustering algorithms can just cluster or group something on the fly, and then based on that, companies or researchers can have proper actions, can take proper actions. And because of that, it's actually the whole process and development of machine learning models is a very complicated and very detailed process. And machine learning development, model development process contains actually multiple sub-processes, let's say. And each step also requires really deep analysis. And then at each step, we have to be very careful as data scientists, and or as machine learning engineers, AI engineers. So right now, actually, there are a lot of job descriptions and there are a lot of titles, but feel free to call yourself as you wish, as you prefer. Like we said, that it's very important to go into details, very detailed, and be careful at each step. But we have to always remember that the most important thing is preparing the data set properly and being sure that you have the correct set of data. So it doesn't matter if you build the best models ever in the world, as long as you don't have proper data set. Because at the end of the day, your models should be answering some business problems and efficiently, should be solving some problems, some real life problems, right? And then doesn't matter if your models are extremely complex and the best models in the world, and as long as you don't have proper data. And also understanding data is very important at this stage as well. Because if you don't have good understanding about the data set, so you wouldn't be able to develop those machine learning models properly. And also, you have to always, at this stage, you have to organize some workshops with the business side to be able to understand data in a better way. So after you are sure that the data set is prepared properly, so then you can move on with model development stage. And model development stage is about trying different machine learning models, different approaches, and maybe some statistical models to be able to answer this business question or answer this real life questions properly, provide some solutions to the real life problems properly. And then, of course, it is always hard to say for which problems and which models work the best. That's why you should always try different type of models, different type of approaches to be able to find which type of approach or algorithm is the most efficient one for your specific problem or your kind of um, business issue, let's say. And as I already mentioned, so another important point, especially in the large companies, so people from the business side, and we are calling them as stakeholders, not always are having technical background. So, and also they sometimes, or let's say maybe even often, see those machine learning models as a black box solution. So because of that, and this, they are sometimes not willing to invest money on this, and they are not sometimes willing to have them on the production. So we can also see it in the financial domain. For banks, those models, those machine learning models and AI models are like kind of scary. So because of that, in our team, we provided some business-based approaches to be able to explain those models to the financial institutions and to our business stakeholders in a more understandable way, not using complicated metrics and then things like this, but we try to find some business language to be able to explain it to our stakeholders. And for sure, for different business problems or for different real life problems, and you should go with the different approaches. But what we also realize after going through different type of projects, different type of problems, actually there are some common steps. So what are they? So basically, understanding data is valid for every type of business problem. So model development is again valid for every type of problems, right? And comparing the model and then observing, monitoring the model performances, again, the same for everything. We're talking about understanding the data, and actually this EDA, so which stands for Exploratory Data Analysis, and which is extremely important. Then it should be conducted at the very beginning to be able to understand data structure, to be able to understand what type of features you have, what are their distribution, what type of statistical distribution they have, if they have any type of correlation between them. So for example, for this part, we use statistical techniques, so basically statistical tests, and they helped us a lot to be able to understand if those features are connected with each other, or if those features are explaining our target values in a better way or not. And then afterwards, of course, time to time, you might have thousands or hundreds of features, hundreds of input variables for your business problem. And it is always also hard to decide which are more important for your problem, which are less important. And there are also a lot of useful techniques, and they are also called like feature selection methods. Even there is a separate part which is called feature engineering. And based on those approaches, so then you can say that, okay, those features are more important for my problem, and then the other one less important, and based on also your exploratory data analysis, and then you can connect those dots and then decide that, okay, I would like to use those features on my models, or to be able to build up my models. And another thing, and which is usually forgotten by companies and also by authorities, which is about monitoring model performances on the production. So imagine that you are using some mobile phone app, right? And then it is using some machine learning models, and which means that if you are able to access this application, which is based on AI or machine learning, which means that these AI models are on the production, so which are already used by end users. So end users are actually us. So basically we are end users, we are using some applications, And then when we have access to those apps, so which means that they're on the production. So they're not on the testing, they're not on the also development stage. They're already released, and then people can access them and use them. But this part is extremely kind of ignored, because companies, after releasing those models to the production, when they go to the production and then put those models to the application, so they just leave those models alone. So they don't check, as long as there is no complaints from the clients, from their customers. So for example, I don't know, I'm using some application which detects some objects on a given photo. And let's say for first 6 months, this application works pretty fine. And then, but after 6 months, because this model or models behind of this app were not maintained properly, and then I'm having some troubles with this application, and I'm writing some feedback and then complaining and so on, and they are realizing that, oh, okay, so our model started to kind of fail, and then we have to redevelop it, or we have to consider how we can improve the efficiency. So this is the kind of a main or like general idea behind the whole talk, let's say. And now let's take a look at this machine learning model development cycle. And I found it on a very useful article, which you can find also on this link, so which is from towardsdatascience.com. And I strongly recommend you, if you are not familiar with this portal, and this portal is extremely cool, and then you can find very useful information there. So machine learning model development cycle has actually three main steps, three main sections, let's say, right? The first, and I think the most important part, is data management and preparing data and then gathering data. And there is also saying that 80% of the whole data science processes is about preparing the data. This is actually extremely true, because this is also what we observe in our daily work. And seriously, sometimes we spend like 2-3 months to be able to prepare proper data set, to be able to understand this data set. And then after all, so then we are going into the model development part. So for us, it's actually the most exciting part, but we are already aware that if we don't have proper data, there is no need to go into model development stage, because if you don't have good and proper data set, and the thing you do related to model development is just useless. Okay, so let's take a closer look at the data management. Let's talk about this a little bit more detail. So what is data acquisition? So you have to receive some data sets, right? If you are having some business problems, or usually you don't have this problem, but usually your company has, or if you are freelancer, your client has, or your institution have, your researcher and so on. So you need some data, right? So sometimes this data is not just given you in some sort of flash disk, or in a very structured CSV file, or kind of in a very structured database, or provided by very structured and very well documented API. So usually, for example, for our cases, and then we are actually digging into it and then finding proper data sources, and then going and asking them time to time to the business side, and then asking them, okay, we need more data points, because after analyzing your data set, and then we realize that the data points are not enough to be able to answer your questions, or to be able to provide efficient solution for your business problem. And then once again, let's focus on again the data preparation. So actually we talked about this a lot, but once again, let's put some lights here. Data preparation, we said that it is very important, and structuring this data and maybe manipulating some features and sometimes, you might have missing values in your data set, and then you might have to input these missing values. So this is also very important step, I would say. And you have to understand if your data set has some outliers, some extreme values. If so, you have to either get rid of them, or you have to consider about proper solutions, because not always it's a good idea to remove those outliers. Sometimes they might have very important information. So that's why it is very important, and it has to be done very carefully. All right. So now we can jump into the experimentation part. So for me personally, it's the most exciting part, because here you can literally experiment. You can play with data and have some exciting results. And when you are training your models, you are putting eye on the accuracy, and then checking what's going on. And when you receive very good results, and so you are getting excited. So you develop the models and you train your machine learning models, and now it's the time for validating your results and going into maybe business, and then discussing about your results with them, and then being sure that they are satisfying. So those results are good enough, and then they can answer this or provide solution to specific business problem. And if you are not able to have meaningful accuracy, or if you're not able to provide proper solution to this problem, so then you need to go back and then take a look at your data set. And then you have to be sure that if you acquire proper data set, if you have enough data source, if your data set is updated, and basically if you have also enough observations in your data set. And then coming back to data preparation, if you think that there is something missing, so fulfill this, and then basically solve this issue related to your data set, related to missing parts in your data set. Come back to data preparation, and also take a look at data preparation part if you prepared your data properly. For example, in our team, we also implemented code review part related to data preparation. So because, like I said, the 80% of our time is spent to prepare proper data set when it comes to providing some machine learning models to solve real life problems. And we are writing, codes, and then to manipulate this data, prepare this data. So what we implemented code review. So for example, let's say if I'm writing some piece of code that is about data preparation, and my code for this data preparation is being reviewed by my colleague, my teammate, and like with fresh mind. And then, so my colleague is asking me some questions, and then we are consulting some points together, and then we are being sure that actually this data preparation part has been conducted properly. So then, once again, turning back to the experimentation part, so we walk through the one loop, let's say, so we are again in this experimentation part. So again, we are going and then checking accuracy if it's fine. And then if we reach out to some desirable, some proper accuracy level, then we can go into the production, right? But this is extremely important part. So for example, what we implemented here, before going to production, we are at least conducting 2 weeks monitoring process, monitoring approach. So what does it mean? So we are doing like this. If our models are connected with some process, and then if those models are trying to kind of reduce the human effort when it comes to this process, what we are doing, we are not saying that, okay, our models reached out some very high level of accuracy, so then we can remove this human effort from this process, and then we can just go ahead with our model. So this would be a very bad approach. So what we are doing, we are running a monitoring process, monitoring step. In this monitoring step, our models are predicting those errors or those failure in the process. And at the same time, in the parallel, the process is going on manually, and then as it used to be. And then we are comparing the results provided by humans and provided by the machine, and then checking how our algorithms manage to provide proper results to solve this specific problem. This is actually very important because going to production means that you are going to reduce some manual process from the process, and then you would just add this automation at the heart of this process. So then you have to be very careful. So, and it is not at the end of the process. So because this is a kind of a live ecosystem, right? So you have to always take care of this whole cycle. When you go into the production, so finally, let's say you put this machine learning algorithms into one mobile app or into some web application, right? And then also you have to be always monitoring your models. So what does it mean? So for example, what we are doing, we are time to time selecting random samples from the population or from the data set and sending these data points randomly to basically real agents, so people like human, our colleagues in other departments, and they are checking those observations manually, and then our model is also observing. So then we are also able to again compare the model performance and the real decision which is made by a specialist and expert on this domain. So what we are also checking, distribution of the features. So we are checking if the distributions in the time frame, if they start to have different statistical distribution. So I mean, in other words, if the pattern of the data set changed in the meantime, right? And we are checking also what type of scores our model is providing, if it is going sort of on the flat pattern, and I will show you in the following slides and how our applications kind of provide solution for this. And then if there is stable pattern related to those scores provided by the model, so which means that things are on track. But if there is unexpected issue, if it goes up all of a sudden, or if they go down all of a sudden, so which means that something is happening. Either data set changed, or something was broken on the system, or I don't know, we stop having proper data feed to the model. So those are extremely important. So that's why you shouldn't actually, you shouldn't leave the models alone on the production. You always show your love to those models and then take care of them. Okay, let's move on. And the first question, this was the question at first place we asked to ourselves. So how to understand data? And as you can see here, Leonardo DiCaprio says that too much data to analyze. We need to go deeper. Okay, very fair enough. But how much deep we should go, right? And how to analyze data. So what does it mean, analyzing data, right? And we have to decide and which way we should go to understand our data set in a better way. So this is the application, that those results are live, and then they are coming from a real live project. But as you already realized, I had to cover some, project specific names, because it would be kind of not good approach if I didn't leave it. So they are confidential. Unfortunately, I had to cover them, but it doesn't matter, I think. So for example, what we can see here, we can see a feature, as you can see, there are some tabs on our application. So first tab is showing us descriptive statistics about the features, in other words, inputs in our data set. And on the correlations tab, we will touch in this point. So we are analyzing relationship between our target variable and input variable, and also analyzing and observing correlations between our features. So let's take a closer look at this screen. So here, as you can see, we can take a look at each features one by one. As you can see here, we have one numeric feature. So, and then we can see also here descriptive statistics about this one. And then here also we can see a distribution. Basically, it is number of, let's say, observation, right? And then we can see also how many cases or how many tasks have been completed by the real agents. And then while having this 2 times. And then here we can see again, so as you can see, majority of those tasks are having 2 connected to this observation, so connected to this feature, and then it goes like that. So if you look at those labels, what the red color shows, for example, red color shows that, for example, for here, and 95% of those tasks have been completed without an error. So basically, those real agents didn't make any error. Just at 5% of those tasks, errors were observed. So basically, it works like that in our process. So experienced agents are processing some tasks related to our processes and our tasks, right? And then afterwards, there are quality specialists, and then those quality specialists are checking if those tasks have been completed properly. And then those are the results after the quality check, let's say. And then it turned out that for this part, and like I said, 95% of the tasks have been completed properly. 5% have been completed with at least 1 error. You know, there can be also multiple errors, but our interest is about having at least 1 error. So which means that this task basically have failed, right? So what is our goal here also? Trying to predict those errors before they happened. And I will give more details in the following slides. So for example, here we can see some categorical variable. So this is type of something, and I cannot tell you what. And as you can see here, for the first type, those real agents completed 7% of them without error. And also we can look at this. So 75% of not having an error was connected with type 3. And the type 3 had the majority, as you can see here, and the 79% of the tasks connected with this type 3. And by looking at the graph, again, we can see the more or less same amount of, let's say, picture here. So for this type 3, the tasks have been completed, and 95% of the tasks have been completed, are not having any error. 5% of those tasks having some errors related to type 3. But when it comes to type 2, we can see a bit different error ratio. So what actually it's giving us? So long story short, it is telling us that basically how our data set looks like, and how those what are our basically features and what they are showing us. So for example, this type can be type of products that are used by end users. So let's talk about bank, right? So, you know, all of us have bank accounts, and then some of us have maybe credit card, maybe some of us have loan and from this bank. So definitely this is not what this data set is telling us, but I'm just trying to give you more example. And also at the same time, I'm trying not to give some confidential information. So let's say we can say that type 3 is about having a bank account or having a debit card. Type 2, I don't know, can be credit card. So type 3 can be having a loan, let's say. And those agents, for example, for 95% of the tasks related to debit card, didn't make any errors. So they basically satisfied the clients. But for the 5%, they failed, and then they couldn't provide proper results or proper service to the clients, to the customers. Let's move on. And we don't have only histograms, we have also box plots. So we can also change and take a look at the box plots to be able to see, at of course high level, to be able to see the distribution of those data set, and also to be able to have some understanding if there are any outliers, but some obvious ones, right? So the box plot is actually a very simple and sometimes is very effective way of checking such outliers. But again, I'm pointing out it's not the only way, because detecting outliers and deciding if they should be removed from the dataset or not, it's a very specific topic. And then you cannot just decide by just only looking at the box plot, okay? And moving on, and here we jump into the correlation part. And as you can see here, we can see two categorical variable, and then we can see how they are differing and how they're affecting each other. So for example, for two categorical variable or feature, and our tool is automatically running chi-square test. And then, for example, for this one, we couldn't satisfy the assumptions of the chi-square. So that's why it doesn't give us any result. And it says that, okay, so sorry, but I cannot run it. So we are also trying to improve this. And then we have some thoughts about this. And we are developing all of those applications using R and on the top of Shiny framework. And for the model development, we are using Python and especially Keras framework, and which is quite useful and quite stable. So moving on, and for example, here we can see one categorical and one numeric variable. And so we can also see distribution of this numeric feature for every different part of type of this feature. So let's say, again, we have numeric feature as something type, or type of products, let's say. And so, for example, let's assume that this bigger kind of chart is showing us debit cards, the client's distribution of having, or kind of maybe expenses spent or realized by using debit card, and then, or something else. So we can see, for example, those different approaches. So here, for example, when we have one numeric and then another feature is categorical, so we are actually checking if this numeric variable, numeric feature, is having different distribution, or if it is differing between different categories. So for this, we are checking the normality assumption, and we can, of course, apply here ANOVA. And if it is failing, this assumption of ANOVA is failing, we are jumping into non-parametric version of this, which is Kruskal-Wallis. As you can see, in such case, our tool decided that, of course, we coded this, so it's not that smart, right? So we basically told the tool that, okay, please go ahead and then check specific assumptions, and then if not, go and use Kruskal-Wallis. So as you can see here, based on this Kruskal-Wallis, and it tells us that there is significant correlation between those features. So in other words, this numerical feature is changing and then having different distribution per each type, per each category. So this is very important information for us, right? We have to keep in mind that this numerical feature will be affected by this categorical value and other way around as well, right? So we have to be very careful and we have to keep in mind when we will be building our models. Okay, let's move on. And another part which is very important, and before jumping into modeling part, which is feature selection. And we are also running some state-of-the-art techniques, but of course, it's not possible to cover all of them, but we decided to go with Boruta technique and random forest and lasso regression. And so when we select here the type of the approach, and on the following table, we can see features selected by the specific approach. And on this chart, we can also see the importance of those features. For example, here, of course, this is Plotly graph, and then it's interactive when we hover our mouse on those circles, so we can see which feature it is. So we can see that this one is having the biggest importance, right? Biggest impact on our target variable. So, and then we can also select here features, and then based on that, we can see if they are kind of confirmed or rejected by different models. So what we can see here, for example, if we are not satisfied with this table, so we are going into details and checking them one by one and saying that, okay, so this mean score something has been confirmed by 2 algorithm, but rejected by 1. So, okay, so maybe we should consider about this and things like that. So the feature selection is very important and very crucial because, of course, there are also common approaches like, removing features which are having variances close to 0 or features that are highly correlated with each other. We are, of course, running this, but also having such approaches also giving us wider perspective. Okay, so then the next question. This was, again, a question which we asked to ourselves: how to interpret machine learning models. So as you can see on the picture, and then there is a very, very curious guy, and then who would like to talk about interpretable machine learning. And I think the best example about interpretable and or explainable AI would be the DALEX, which has been developed and which is being still built by Biesek, Professor Biesek, and he is Polish, and then he is actually quite important person in the community and then related to this domain. And as far as I know, he is working in Warsaw Technical University, but I might be wrong, or Warsaw School of Economics, I don't exactly remember. And he did quite good job here, and he provided quite important R packages, and which kind of provided very wide view to the researchers. And we are also at the stage of implementing those approaches to our tools and then to our process to be able to understand, to be able to interpret those machine learnings in a better way. There are also other methods like SHAP and so on. So they also allow you to understand efficiency or importance of those features that are used to build those models. All right, so I was telling you that we somehow invented a business language. So of course, we are checking ROC curve and then checking, area under the curve. But this chart is not showing us a very standard ROC curve. This is something different. So what we are saying here to our business stakeholders, because they would like to check how many errors have been conducted by the agents, but they are not having enough time to check all of those tasks, right? So that's why we are providing them such understandable graphs from their perspective. We are saying that, okay, you don't have to select or take a look or check all of those tasks. You can check the specific 80% of this of those tasks, and then which will allow you to detect 90% of the errors basically conducted by the agent. So you can basically definitely comfortably assume that the rest of this 20% didn't have any errors. So comfortably you can just skip them, and then it would actually cut 20% of your workforce. And considering that there are like millions of tasks and millions of clients and thousands of things are happening in the financial domain, cutting 20% of the workforce and workload means a lot. And you are cutting the cost 20%, and you are able to use your resource properly, and so on and so forth. And we are showing them also this, let's say, business-based chart, and for our train set and for our test set. So then we are also trying to say that, okay, our models are stable, and we are also implementing different type of models, and this part is also being updated related to our experiments, let's say. Okay, so there is another issue here. Okay, we interpreted our machine learning models very well, and we are pretty comfortable with them. And we reached out very cool, let's say, accuracy level, and on our validation set, test set, also accuracy was okay. And we can say that there is no overfit, and our data set is working pretty fine on the data, which is not seen by the model before. But another question, so how can we sure that if we don't have a good model, or if we have a good enough model, or maybe if we have insufficient data? And this is always very important issue, because you might have a very good model development process, and you might achieve very good results, and you might provide very high accuracy. But what you have to do, you have to check it, kind of so-called monitor those results before going to production and being sure that this accuracy is stable. What we observed recently, we developed some models related to natural language processing, and on the training part, the accuracy and performance was great, excellent. So everybody was excited. But we ran 2 weeks monitoring on the real data. So basically our model provided some results, and we didn't know what was the real answers or real results provided by real agents. And then after 2 weeks, we put those 2 results next to each other, and it turned out that our accuracy dropped 20%. So we were like, oh my God. And then it turned out that we literally missed a couple of very important things in our data set. And then we turned back to model development, and then redeveloped our models, and again go into this experiment part, and then validation part, and then go into another part, basically period of monitoring part. So, and then afterwards, we will decide, actually it's still going on, and what I can tell you, then afterwards, we will be able to decide that, okay, finally models are stable, and finally models are providing with the production data quite stable results and quite similar results with the model development results. And so this is the first part, for example, here, and we are summarizing those results for the business and telling them, okay, those are the results provided by different models, and those are some cutoffs. So we can see, okay, by checking 25, 50% or different parts of your tasks, and then you would be able to detect that amount of errors, and those are the differences between different type of models. And they are quite happy with such results, and they can see, and then they can have a business decision. So they can say, okay, so I'm okay with taking that risk. So then we can agree that I would like to check only 75% of the tasks, and then I can take this risk. This is acceptable, and this risk is still lower than having totally manual process. This is actually what we realize. So we are able to provide them lower the risk, and and then at the end of the day, the risk is quite low compared to the manual processes. So my dog visited me. So if you hear some strange sounds, so it's not me. Okay, so another thing is that how to be sure. So we talked about a lot of things and monitoring and so on, but so as I was saying, we shouldn't leave those models alone on the production. So how can we sure that models are still good? So of course, we shouldn't always behave like a guy on the left-hand side. We shouldn't have very high confidence about our model's accuracy, and we shouldn't even go into production without validating results. This would be a scandal, not like the guys on the right-hand side. So as you can see, they put the models in production without testing data, testing the model on the validation set, so which would be a scandal, right? So they seem they're having fun, but this is actually not a fun. Okay, so what we are doing related to monitoring the model performances. So, and when the model is on the production, so we have different metrics, and we are observing on weekly, daily basis, and different parts of the data. And also we are going into monitoring period, and then in detail, and also model development period in detail, and then checking the data or model results if they somehow changed in the meantime. And we have different metrics, so part of the tasks and error ratio and score and so on and so forth. So here we can see that if our model accuracy changed within the week, so we can see that something happened here. So we have to definitely go into details and check what happened there. And so what else? So we are also, so this is the kind of monitoring related to model development part. So this is the monitoring related to production, right? So we can see that how many of those cases or tasks have been assessed by the models, and how many of them have been assessed by the people, and then how many of them just only ignored or just moved into the completed stage. And this is a kind of giving us an overview. And here we can see that there are different parts: model performance, details, and comparison part. On the model performance part, we can see that, so basically, I was saying that we also are having some random samples from the data and on daily or weekly basis, and we were observing the changes. And here we can see also those scores provided by the model and how they behave on the model development data and how they are behaving on the production. So if you're observing something kind of weird or unusual thing, so we are immediately going into details and checking what happened there. And what is more, so we are also checking distribution of the features. So for example, on daily basis, we are able to check distribution of the data, even categorical variables. We can see that if they somehow changed daily basis, if they are more or less having similar distributions or not. And here we can have also some bar charts, and then take a look. And here we can see that there is again Kolmogorov-Smirnov testing is being run to be able to compare statistical distribution of those features on daily basis. So for example, or weekly basis. So for example, here we can say that there is no statistical significant difference between 23rd of November and 20th of November for this specific feature. And there are also those two buttons here, and they are providing quick check to us. And there is also email notification. So when we click, for example, check scores, and then it is just running very simple method on the behind, and it says that, okay, I was scored for the recent time. It is within the IQR. And then it's here also the other button, which is about checking features distribution. And it says that, okay, so we detected statistically significant difference for 9 of those features. So which means that within the time, distribution of those features change. So we have to be very careful about them and then be sure that it is not affecting our model performance so much. And last but not least, so we are also having some automations about this. So this is also a very important thing. So, and this part, it was our pleasure to automate them. And also we created some logs related to this automation, and we are observing what's going on related to this automation. And one by one, we can see and within some time frame what is happening or what happened. So how many, observations or data points have been assessed by our models and how many of them not. And there is an API here. So basically it is based on Node.js. So our Python scripts are running and then sending requests. First of all, our Python scripts are running, sending requests to this API to receive data. Again, other Python script is running to run those to be able to provide machine learning model results. And then again, based on those results, we are also sending some requests to the this API and then saying that, okay, hey, so those are the results, please take necessary actions. And on the following screen, so we can see the responses of the API. So if we see here 200 response code, which means that everything is fine. So as you can see here, we can see also different logs, okay, saving the results and then updating some data points and then calculated some different things and then so on and so forth. So this is pretty much everything for today. Thank you for your attention and thank you for staying here. And I can see that like we more or less finished more or less same amount of people as we started, so which is very cool. Thank you so much for staying with us. You can reach me out via those email addresses. So both university address and also for the company address. I will be glad to try to answer your questions.
Thank you very much for this presentation. It was great. I'm inspired. I can see that we have a few questions on chat. How are you today, sir?
I'm fine. How about you?
Okay, so Hala Nelson, excuse me if I mispronounce it, ask what software do you use to analyze your data and do models, and how many real-life problems have you worked on?
Yeah, very good question, I think. And for this data exploration and comparing the model performance, and okay, so you can see my dog, so he's trying to join me. And so for this part and for this visualization and the web app you saw, it is based on Shiny framework, and which is one of the frameworks of R. So as a technology stack, we are having a Linux-based development environment, and we are using Red Hat distribution on the top of this. And we are also using Python for model development, and also creating some job schedulers to be able to run those scripts in an automatic way. Yeah, I think this would be the answer for the first question.
What kind of job scheduler do you use?
Sure. Usually we are going with cron job because this is the easiest way for us, but we are also investigating different approaches with our DevOps team. Because cron jobs sometimes are not flexible and it's not so easy to configure them. So we are at the stage of changing maybe this approach. Yeah.
Okay. I cannot see any more questions on the chat.
I think there was a
Oh.
question about how many real life problems that you
Oh,
have solved.
sorry. Yeah, of course.
Actually, it's really hard to answer this question. And so considering that I've been working as a data scientist for more or less 8 years, and I've been working also in very different line of businesses like defense industry and real estate finance, and again right now fintech. I was solving real life problems related to marketing and optimization, also some machine learning based predictions, clustering approaches, and so on. I mean, very hard to say exact number, but I can maybe answer it like that. So.
I can see a new question. Question just popped up. What if a company forced the worker to work on small data where the accuracy is reaching 95%? What to do? Is it necessary to work with more and more data, which lead to down the accuracy?
It's actually a very good question, and it is very tricky because so again there's a question. So, and how small this data it is. So sometimes accuracy, yes, lowering the accuracy is not a good thing, perhaps, but if when you're expanding your data set, if the accuracy is going down, so which means that your first model wasn't efficient enough, because probably this first model wasn't able to see enough pattern in the data set or enough pattern related to business problems. And of course, when you're expanding your data set, you have to be very careful if you are having more or less same type of features and also related type of features connected to your business problem.
Great, thank you for this answer. What data preparation includes? That so it then can take even 3 months, as mentioned.
Sure. Actually, again, the most let's say time-consuming part is having workshop with business. So they are first explaining us their aim, and then they are kind of sharing with us their data set. And first we are spending and trying to understand relation between those features. And first of all, even if there is some type of relational database, first we are trying to understand their logic. And then afterwards, there are again some sessions, periodical sessions, which sort of in the form of brainstorming and knowledge sharing. And we are going and saying that, okay, we discovered, let's say, 30% of your data are investigated. So this is our understanding. Is it correct? So they are saying, no, you totally misunderstood. So then again, coming back and understand it properly. And another part is also related to create some features that are very valuable for us. So for example, you actually could see a little bit, but mean value of something. So those features are actually sometimes created by us. So we are taking into account multiple features to be able to create another feature. Because time to time, we are given very low amount of features. So then we have to consider how we can expand and then how we can benefit more from this data. And then next, I think topic, which is again very time consuming, related to understanding the outliers and the pattern and the distribution of the data. And again, deciding on if those observations should stay in the data or not. So if they have very important information or not. So should we sacrifice them or not? So, and this is another thing. And maybe last thing is also if there is any missing value, again, should we remove those observations or should we try to input them? And then if we are going to input them, which techniques we should use and how accurate those techniques will work.
Great, thank you.
Welcome.
There's another question.
Okay.
What technology do you recommend for beginning with data science? Have you ever heard of Julia?
Yes, I heard about Julia, exactly. And this is pretty cool framework as well. And as far as I know, even PyData community is supporting Julia framework as well. But this is my personal kind of judgment, or even maybe let's don't call it as a judgment, a personal impression. And when it comes to R and Python, you can reach more amount of free sources. And also when it comes to R and Python, you can see a bigger amount of libraries, packages that might help you to deal with some problems. And the community behind R and Python is wider than Julia. But of course, this is again great language. So, I mean, you can even go with Go language if you would like to do something. So this is definitely up to you. And but what I would recommend personally, like go with maybe Python on R at the very beginning to be able to reach out more sources. And there are even a lot of tutorials on the internet, a lot of courses based on them. I think this would kind of speed up your learning process.
Great. I can't see any more questions, but I prepared a few myself.
Okay,
so
cool.
I hope that you'll find a few more seconds to answer this.
Sure, definitely, I'm fine.
So at one of my meetings, I was asked, what do I think of AutoML? And do I think that it will replace data and machine learning scientists in the future?
Mm-hmm. Definitely not, because as you can see, this process is quite complicated. So always there is a need for human. So especially for the data preparation, right? So, okay, you can automate so many things. So we also did. So for example, we automated hyperparameter optimization and then deciding which model is better than others. And we automated feature selection process and so on. And without human effect and without vision of a data scientist, then this type of things are very hard because this AutoML cannot understand the business problem. But as a data scientist, you are putting something from your side as well. Because unfortunately, when it comes to real life problems, not always you have very structured data and very structured, basically a very structured environment to be able to provide solutions. Yeah, I don't think so that this will replace us. Of course, this will help us to automate some time-consuming parts. Again, definitely apart from data preparation, because this requires a lot of attention. But perhaps when it comes to this, hyperparameter optimization and so on and so forth, probably this would help us to speed up some process.
Thank you. I did some research on the topic myself, and yes, as far as I'm concerned, this will become a great tool for data scientists, not a replacement.
Exactly.
There's another question on the chat. In a collaborative work in machine learning, how to divide a project between people? What should be the point to focus in diving a ML project in team? Take example as sentiment analysis. I don't know what does it mean.
Sentiment analysis, so which is a task related to NLP, natural language processing.
Okay.
Yeah, actually, very good question. And splitting tasks within the data science team very tricky. And so unfortunately, this is my task within the team. So I'm having very hard times. So because this is very tricky, you know, you cannot divide the model development part into two parts. So, you know, if a person starts to develop one model or some type of models, it's better for this person to continue with this approach. And but also it's not good to just put all the load on one person. And so what we actually are having, so kind of our approach, but it is not the best approach, of course. We are constantly considering. So we are, for example, dividing data preparation parts and giving data preparation to maybe two different people, and then saying that, okay, please focus on this data source, and then you focus on this data source, and then we will review those your codes, and then you will create pull requests, and then after review we will merge them, and then we will pass the script to a person who will take care of the model development. So if those candidates models are quite a lot, usually it's better to develop more models. And if it is getting a bit more complicated, so we are also sometimes dividing this task into between 2 or 3 people. But this is personally nothing that I am very happy about, because, you know, based on like my experience, it's better to, you know, if one person take care of the model development, but definitely with the help of other people in terms of code review. So so what we have also in our team, we have in our team, again, experienced data scientists, but who are taking care of preparing business requirements for us. So they are in touch with business stakeholders, and they have advantage because they have data science background. So they can basically convert those business requirements into sort of our language. So I mean, data science language. So then we don't have to deal with understanding those business problems. So I think this is a kind of an approach. But for example, what I experienced in previous companies, and applying or implementing Scrum methodology in data science team is also a very tricky part. Again, it's connected with user stories. So how would you assess that if a model development part will be complicated or not? Because sometimes you cannot assume things, and then you cannot assume how things, how much things will be complicated, and so on. Yeah, I think this would be my answer to this question.
Great. The same person who asked the question asked whether they can have your LinkedIn account or name.
Yeah, sure, definitely. So if you,
I may paste it to the chat or to the description of.
I can even like copy and paste.
Oh, I already have it.
You already put it? Okay, great.
Yeah. I have another question for you.
Yeah, please.
What resources do you use to stay up to date with the so rapidly developing industry of data science and machine learning? And are there any books you would feel comfortable to recommend for us to read?
Sure. I don't exactly remember that there is statistical, I would say statistical machine learning, but I can maybe write it into the comments later on, because statistical, okay, I will just think about this. But what are for me, what were the most important resources? And the courses on Coursera, for example, and especially Andrew NG's courses and Geoffrey Hinton's courses, because, you know, those guys are like god of the data science and god of machine learning. So Geoffrey Hinton develops those AI algorithms at the end of 80s, 90s, but nobody understood him. So And nowadays we are just benefiting from his approaches and his methods. So, and definitely those resources would be beneficial. And I'm also trying to follow archive.org. So there are, new type of researchers related to this domain. And I'm also trying to follow very important data science conferences like ICML, for example. And again, so rock stars of this domain coming there and then sharing their experiences. So people from Facebook AI and Google Brain Team and so on. So those are the, I think, resources. And I'm also following a couple of researchers, like I said, Hinton and Andrew Wenju, and maybe they are not actively writing papers, but they have their students, PhD students, and they are writing very cool articles. And also Yoshua Bengio, and he used to be, I think, head of Facebook AI research, and he has also very cool researches. And one book came to my mind, which was written by his student, his PhD student. It's called Deep Learning, and it's open, but unfortunately you cannot download PDF version, but it's in the form of website. So if you just write deep learning book, so you would find it. And of course there is a possibility to order hardcover. But I benefited from this book a lot when I was writing my thesis. So it was very useful and explanation was very clear.
Great, thank you. There's another question from Damian Man City. Is Python better for data science than R?
Yeah, I remember he asked this question in person to me as well. It's really hard and tricky to say something. From some perspectives, R is better. From other perspective, Python is better. So, for example, why I like R, and because those libraries or those packages are quite up to date, and also you can find some packages related to some papers quite soon, and you can also find very specific packages related to some specific problem. So because of that, I really like R, and also I really like their package releasing technique. So it goes through a lot of tests. So before the packages are released on this cron repository. So that's why I really like it. I really like R from this point of view. And for example, why I like Python, and it is quite easy to implement it with some backend. So what we are doing, for example, we started to develop models in Python, and then we started to use Python as a backend. So using Shiny framework as a front end. So calling Python script from our environment. And from this point of view, sometimes it is better to go with Python, and sometimes it's better to go with R. But I don't think so at least I cannot say that one of them is best, but of course, R is having very special place in my heart. So, but I don't want to be biased. So.
And do you think that, let's say, a modern data scientist should learn both of these?
It would be very beneficial, to be honest. And also, of course, for the data scientist, having very good SQL knowledge, so query language knowledge would be very beneficial. And I think those three kind of languages languages would be extremely beneficial, I would say.
Great. Let me just check it. I have another question for you. I do actually. How often do you communicate with the data engineering team at your company, and what does such communication look like?
Yeah, a very good question. And I actually forgot to touch this topic during the presentation, and thank you for this. And yes, actually, the communication between data engineers and the data scientists are very important. So I would say quite often we are in touch with them because they are preparing those data lakes, and they are also basically providing us data, right? So they are building up the whole data source, and so that's why. And I was even learning some big data frameworks just to be able to communicate with them. So I'm not saying that they don't understand, but I'm saying that I wasn't able to understand how I should ask the question. So that's why I learned a lot of, maybe not a lot of, some topics related to big data frameworks. So then I was able to go and ask them. And so, yeah, actually, I would say data engineers and data scientists should be the best friends with each other. So in terms of collaboration, yeah.
And do you see that happening in the companies that you worked in? Does
Yes.
data engineers communicate well with data scientists?
Yes, definitely. So, yeah, for example, there is one experienced colleague, and I'm learning a lot of things from him, like in terms of processing the data and so on. So it is very interesting.
Great. Thank you for that answer. And I can see new questions on the chat. Do you do any collaborations with academic institutions?
So I'm working in Polytechnica, if you call it as a collaboration. Yes, I'm conducting courses there, and then I'm doing also research. But yeah, I think this is let's say my academic institution at the moment, I would say. Yeah, I'm also in touch with some, maybe not academic, but some institutions, foundations like YR, for example. They're very active in our community. And I'm also in touch with other sort of foundations, so related to data science and so on.
Thank you. Wojciech Wicki also asks, how does a typical day at work as data scientist look like?
Yeah, a very cool question, I would say.
And maybe I'll add, what do you like the most about such day?
What's, once again, sorry?
What part of the day do you like the most?
Okay, yeah, cool. So maybe I can start with your question, because it is a very nice one. So I think I really enjoy this experimenting part. So trying different models and discussing with colleagues and finding proper approach and so on and so forth. But when it comes to the first question, like first part of the question, let's say, and our daily work life, let's say, or our daily work looks like that. So if we are, for example, already, if we already started some, process or some, project related to model development, and of course, this is having always the biggest priority, and then to be able to complete this task. So what we are doing, so we are coming to the office, of course, right now, home office. So we are changing the room from bedroom to working room or living room. So, and then connecting to environments, our development environments. And then first of all, what I'm doing, I'm checking if all the Docker containers are working, and because our apps are served via there. And then also checking also those monitoring applications which are showing us results related to models on the production, and checking if they're okay. And so then conducting our daily works, either about data preparation or about model development. And yeah, I think it looks like that.
Thank you. And I think that, okay, we have another question.
Sure.
Could you recommend any big data platform? And the follow-up to this question is something where you can learn about Spark, etc.
Sure. I would say, yeah, Spark is very cool one, and there is also MLlib API of the Spark, and there is also PySpark and Spark R. So then you can use Spark from like using Python or using R, and both of them are pretty cool and pretty stable, I would say. And Spark, like it's connected with data processing, and also there is another API which is called streaming, so you can manage stream data, real-time data, and even run some machine learning on the fly using the stream data. And also they have data frame API, which is pretty similar to the R data frame API, so which allows you to manipulate data quite easily. And so if you are dealing with huge amount of data, and if you would like to prepare your data set, so Spark would be very beneficial. And they have also RDD API, so it is very quickly and in a distributed way processing the data set. MLlib is also, again, very fast, providing very fast solutions. What I would also maybe say that Hadoop ecosystem is also pretty important. And because if you would like to process some data, you would also need to have some data lake. And so what I was, for example, learning, and I was learning some query languages running on the top of Hadoop ecosystem, like Hive, Impala, and there's also Peak, I think. And so they, especially Impala, was very impressive. So it was running quite fast, and you would be able to run complicated queries like on terabytes of data very easily. And this would also, I think, of course, like for data engineering, definitely very important, but this would also help, I think, data scientists. So I was benefiting it a lot. I was provided access to the Hadoop ecosystem and writing my queries on my own to be able to get the data. And so basically data engineering were pushing the data to this data lake, and then it was helping a lot. Related to something where we can learn about Spark, and again on Coursera, there is very cool specialization. It is called, I think, big data specialization. And also there is one good company which is called Databricks, and this company was founded by inventor of Spark, and they have also very cool work, how we call it, like collaboratory workflows. And so there is also even community version of this, if it still exists. I haven't checked it recently. And Databricks is also providing some courses, and they have also, yes, exactly, it is called Databricks. And so they are also providing some certifications. So, and this would be also very nice to have, perhaps.
Great, thank you. And another one.
Sure.
Is it okay if I just keep the knowledge of supervised learning instead of the of other like unsupervised? It will be okay to work in future companies and keeping just focus on supervised learning.
I think again, good one. And I would suggest to focus on both of them, because sometimes it is really not possible to have a labeled data, or sometimes you don't have enough time to label this data. And also sometimes you don't need even labeled data. So if you are, for example, trying to group your customers based on their expense trends, and then so you can run clustering algorithms for this, for example. And then this would also help you to group your customers based on their transactions. And I would say both would be extremely beneficial if you are asking me. And then, yeah, I would say focusing on both would be better.
What about reinforcement learning?
Yeah, Definitely, this is quite important recently. And you maybe heard about this DeepMind, so which was acquired by Google. So they were having some challenge related to Go game. So this algorithm was built by using reinforcement learning techniques, and it was having self-learning. And the algorithm managed to beat Go champion. And so there's even a very cool documentary about this on Netflix. That they also their algorithm managed to beat Kasparov, I think, when it comes to chess. I'm not sure if it is DeepMind, but they also again developed some reinforcement learning algorithm to play video games. So this
Dota
is
2, for example, right?
exactly
Or League of Legends.
Exactly, definitely. So it will be a kind of, I think, our future reinforcement learning. So because it is learning itself, let's say shortly maybe. So yeah, if you can start on this, that would be amazing. Yeah.
In future, which will be more important in future challenges, supervised, unsupervised, or reinforcement learning? I think that you answered this question in your opinion, reinforcement learning is kind of the future.
Yeah.
And I'd like to also ask you, what do you think about Elon Musk's Neuralink? Have you heard it? And
yeah, it is, like amazing. I would say very impressive. So Elon Musk is also basically doing quite cool stuff related to these domains. So for example, Tesla cars, right? So self-driving cars, and they are amazing. And Neuralink also was like, when I heard about this, I was like, oh my God. So this is like kind of, how we call it, there are some events or some things in the history that are changing the age. So if this action or if this happens, so then you are starting to different age. So for example, this happened with the invention of the internet, right? So it might be something like this, but of course it's so early to say something like that. So we will see, to be honest. But long story short, I'm really impressed by this.
Yeah, it seems a bit like a Black Mirror episode going into real life.
Yeah. So let's hope it will not be that scary.
Okay, I cannot see any more questions on the chat, and I ran off mine as well. So I think that that will conclude. Thank you very much for coming. I really learned a lot from your lecture, and I really do appreciate your time and effort. I hope that you would like to join us again sometime in the future. And yeah, thank you very much, and thank you all for coming. I hope that you enjoyed it as much as I did.
So thank you for inviting. So yeah, I will be more than happy to join again. So it's my pleasure. So I enjoy basically talking about this topic. So for me, it's not a problem.
Okay, so yeah, I think that we can stop the stream now. Thank you again, everyone, and see you next week on my Data Science from Scratch series. Bye.
See you. Bye-bye.